Hello, everyone. Maybe before I start, I will tell you a few words about this presentation because it's a highly technical topic, and I'm very happy that you all decided to join me because it's a little bit on the side of the game dev. And my talk would be cross-discipline because it will be somewhere in between DevOps, server administration, cloud infrastructure, game dev, and so on and so on. So it will be highly technical with highly specific technical because everyone in this track every talk is technical, and I will try to cover the areas for this topic as well as I could. And if you have some questions about the topics I've purposely omitted, just grab me after the talk, and I will try to do my best and explain everything. Okay, my name is Leszek Krupiński, and I'm working at CD Projekt Red for 3 years now, I think. And currently I'm working as lead software engineer at online services department, and this department is quite new in our structure, and it combines everything online related that might be helpful for our games. Everything I'm discussing today is created as a part of R&D project called Game In. So this was devised over time for purpose of designing our architecture for our future projects. So let's start with the topic of multiplayer, and yeah, I think most of you will know this iconic photo of a LAN party with people so keen to play together that when they had no free space on the floor, one of the guys is taped to the ceiling, and on LAN parties everyone could become everyone's computer could become a game server because it was the processing power of a single computer was enough to play the game and to host a game session. And the parties over time sometimes became bigger, and the requirements for both the game servers and for the venues have changed. Like you can see, there are a lot of players, and the game servers that hosted those gaming sessions were bigger. There was a need for the servers to become a dedicated entity outside of single player computer. And the other purpose was that the game server is a source of truth. So everything that's happening on the game server decides if it's really happening to avoid cheating and so on. And as you can see, the venue also needed to be scaled up to host everyone. And like I said, the dedicated game server is an authoritative source of events. So the game client sends the intent that the players want to do. Like the player pushed the button, that event is being sent to the server, and server is processing that event and sending back the results. As for the game servers, it's very specific that most of the things are being held in memory. So that's different from many of typical applications of the dedicated servers. And to connect to this server, of course, it's necessary for the game client to know the IP address of the server and the network port to connect to. And that's a very important thing that I will be touching in a moment. Also, the length of the session is can be different depending on the gameplay type, because for some fast-paced multiplayer games like the old school Quake, it could be just minutes. For games like StarCraft, it could be also very low minutes, and for games like MMOs, it could be like it's indefinite to keep the session. So the requirements for the game servers could be quite different. The game servers have some very specific requirements, like the very low latency, because if the game server lags with the responses for processing the events that the player sent, the game will be laggy. So players don't like laggy games. Also depending on the type of the game server could be very heavy, because some game servers carry all the assets that are being used in the game. So it's not uncommon for the game server to be multiple gigabytes of like the binary and associated assets. So it could be very heavy. Also, the specific thing that that's often associated with the game servers is the pre-warming, because like I said, the game server can contain a lot of assets, and spawning new session can take a lot of time for the game server to load all the assets. So quite often the game server orchestrators are just spinning up the game servers beforehand for the player to have a better experience, because all the assets would be already loaded. Also, it's quite often that instead of cleaning up the session, the game servers will just be terminated as a preparation for the new session. For many games, the typical flow of the game servers is to pre-warm, wait for players, start the session, wait till the session ends, and after that, this server is being killed, and another server is being spawned in its place. The typical way of running the game servers up to some time ago was just hosting the games on bare metal, meaning that the company was buying or renting physical servers that were running the games. When the requirements were that we needed to host more players, we had two typical options, like to scale up, meaning that to have better, more powerful servers, to buy a better hardware, or to scale out, meaning that we're gonna have a lot of smaller servers, but with the increasing requirements, we would just add them. What are the downsides of that approach? The problem is that there's very low flexibility of that approach, meaning that first, when we buy servers, it has a rather large lead time, meaning that we have to order those servers. We have to prepare for some anticipated bigger traffic beforehand, like sometimes even weeks ago, just to make sure that we're going to have this hardware. And if you want to scale up, it's even more difficult, because usually we have to purchase better hardware and to replace our old one, or to have some spares to be able to handle downtime of a single server. So that takes a lot of time, and I think bigger problem is that we have to be prepared for the peak traffic, meaning that, for instance, we are releasing some new content, and we have to be prepared to host so many players that are going to be on this peak, and this peak usually can be decimated in the matter of hours sometimes. So we have to have a huge overhead of computing power that won't be used that much quite soon. So that's the issue, that we're going to have a lot of processing power that won't be used a lot. Also, the problem is the long-term commitment, meaning that when we buy the hardware, we're going to have that. We cannot. It's not easy to sell that, and it's especially not easy to sell the server hardware because everyone wants, when they are buying server hardware, usually they buy the top-notch hardware and are not that keen to buy second-hand hardware. And if we rent out dedicated servers, it's also usually as a long-term commitment, meaning that we agree to pay for this machine for many months. So. Like with the LAN parties, we needed to have bigger venue, and if we bought a huge arena, we do not have so many players to fill that area all the time. And also with the servers, when we buy the servers, it's not usually possible to fill it up to the top. But of course, there are, as with the venues, you can just rent out a conference room with like the moving sliding doors to best suit our needs. We can also rent out server capacity. And here comes the cloud, the buzzword for 15 years or so. I assume most of you know what's the cloud, but I'm going to do a short recap because some of the terms will be abused later on. So the cloud, it's sometimes we think of the cloud like some abstract data processing lake, like magic and unicorns. But it's usually just someone else's computer. So someone has to have this computer, and that provider is renting out some capacity for us. And it comes in many different flavors, and it usually boils down to how close to the hardware we will be. So we have the infrastructure as a service, where we just rent out something that we might consider a virtual machine. So we have to take care of we have to go down to the operating system level. Then we have platform as a service, when we just deploy our applications, not thinking that much of how it will be hosted. We just deploy that, and it's magically run by the cloud vendor. Then software as a service, where we just pay someone money to run some software for us, and we are just using that. And also function as a service, which is something very forget the word. Function as a service is something very volatile, meaning that it's just a piece of code that is being run, and we are being charged for the time it's being run. And we also don't have to think that much about how it's run, at which virtual machine, on which operating system. It's just, we just upload the code, bam, it works. It's processing things as we need. Right now we have, I think, three main cloud operators: Google with Google Cloud Platform, Amazon with AWS, Amazon Web Services, and Microsoft with Azure. So those are the main cloud operators. With some, of course, there are many more, but I think those are the most recognizable ones. Pros and cons. Like advantages, of course, the flexibility, because we can choose which which instances we are using, and we only pay for the time the instance is being run. Downside, we have to pay for it like more, recognizably more than for the bare metal, because we have to pay for the cloud operators to keep the machines up and running, whether we need them or not. Hoping that someone will pay them for the processing time. The downside might be technology that it's using, because it's usually virtualization, and with that we have the usual problems, meaning that there's a problem of noisy neighbor, because we have our virtual machine that's being run on some bare metal hardware, meaning that we can have some other virtual machine not belonging to us running on the same hardware, and that other machine can be obstructing the processing power that we need. So it shouldn't happen because it's virtualization, but unfortunately it can have adverse effect on our software. So sometimes we've noticed that it's quite often if we have some performance issues on our machine, we just destroy that one, create a new one, and it's fine. And it's usually because we have that kind of neighbor. Another problem is that the input-output is being passed through more layers than it is with the usual way of connecting with the bare metal. And we also have the tech stack that's being offered by the cloud operator that might not be our first choice, but we would have to comply to that if we want to use things, especially like platform or software as a service. We are limited to some technologies that the cloud operators are offering. So we've decided in our study that we want to focus on running the multiplayer sessions in the cloud, because we were using technologies that were fit for being run in the cloud, and we also wouldn't. It would be easier for us not to take care of maintaining the hardware. So we are starting to see how it might go. So that was our initial approach. That we started putting out building blocks for our architecture, and because it's everything besides the game server is in the multiplayer architecture is more or less the same in all the web-related technologies. So having a lot of experience with things like microservices, we've decided to go with very lightweight components and to assemble everything as we go. So the first thing that we created was the coordinator. That was the connection point for the game clients, and that was coming from our experience with Gwent, because in Gwent we also have the borderline that the game client is connecting to. Everything behind the coordinator is being done internally. So nothing is crossing this border. And the coordinator was doing some things behind the scenes, and one of them was connecting to the other component, which was the session assigner. And the session assigner was tasked to find the best suited game server, mark that game server as occupied, and to return the connection string to that game server to the player. It included things like the authentication code to make sure that this game server will handle the session for that given player. So yeah, we've decided to use that lightweight agents, and we wrote them in Go, and that was because those components were designed to have very low latencies and to handle a lot of connections concurrently and as fast as possible. So that was our choice. We also had some experience from previous projects. Also with Gwent, the coordinator was written in Golang, and having that architecture with small building blocks allowed us to create some components that were more dedicated to the technologies, to the platform we chose to use, because we had for the web services we had experience with using containers, and we also decided to go with that way. And containers are getting it's all the hype for some time already, but those technologies are getting more popular even with the heavier binaries, let's say. So after consideration, after testing, we also decided to put even game servers in the containers. It made a lot of things a lot easier for us, because the deployment, especially for our test purposes, was very easy, because it was easy for us to develop the game servers and also the services. We had exactly the same containers being run on our development machines, on our staging environment, local test environment, and in the cloud. So when we created a single container, we could use them in all the places. And when we created this container, we pushed that container to a container registry, and it was ready to be deployed in Kubernetes. And Kubernetes, if you don't know, is a container orchestrator that's being widely used in the cloud. So that's the technology that's allowing us to deploy containers in the so-called pods, because pod is the smallest building block of Kubernetes cloud. We use usually it's a single container, but it can be it can be made of a few of them. And when we have Kubernetes cluster in the cloud, which we can just click in the cloud panel. We just said how many of those pods we want to have running, and that's just it. We use name of the container that's being held in the registry, and that's it. It's being scaled into as many copies as we want. So we push it to the registry. We deploy that, set how many of them have to be running, and it just works. Except sometimes it doesn't. But yes, that was the development process. Kubernetes has a great way of talking with that cluster. So there's the API that we can use to check how many of the pods are running, how many are required, what are the IPs of the containers, and so on. So we added a new component, which was the session assigner agent that was talking to that Kubernetes API. So the flow was that player connects to the coordinator, asks for a gaming session. Behind the scenes, it also does matchmaking, but that was not the part of the presentation, so I'm not covering that. And when there was the match for many players to play a game, it connected with the session assigner to check to get URL for the game server for that game to be played on, and the session assigner had the address of the assigner agent that would actually assign this game server. And this assigner agent was able to ask the API, do we have any game servers available? If so, it marked that given game server as assigned and returns all the credentials to connect to that game server to the player. So we were able to use that API to skip any kind of creating any kind of backend to hold to keep the list of the game servers. We could use that API to do that for us. If we had that need, we were able also to say, okay, we are running low on the game servers, add some more of them. And if we had hardware, we could just create them instantly. So that was the initial way of running the game servers. Besides the typical issues of running large binaries in the Kubernetes cluster and some networking issues I will be discussing in a moment, it was working quite smoothly. And we also used some dedicated extensions dedicated for the game servers like Agones, and I will do some advertisement because I have a second talk tomorrow at 11, and I will be talking specifically about some easy ways of hosting the game servers on in the cloud using some software offered by the vendors, including Agones, that was helping us with the scaling issues that we encountered. Okay, so that was the simple thing. We have a Kubernetes cluster running in the cloud. We connected to that assigner. It returned the URL to the player, handle everything nice and smooth. But we started planning some deployments, and we were looking for. We just started looking at the map, and we saw that a single cloud operator has some data center just spotted over the continents and so on, and we were thinking, okay, but we want to have our games to have lowest latency as possible to make the experience for the fast-paced games very smooth. So we looked at the map and compared offers of different cloud operators, and we noticed that yes, they have data centers within the same countries, but quite often in different cities, in different areas. And in Europe, it might be not that big of a deal, but in the US, it could be a matter of huge difference in pings if the Central American region would be in Chicago or in Denver. So that's a huge difference, and we thought, okay, maybe we could try using multiple operators to hold our game servers. The other thing was the price, because of course it's understandable that different vendors have different prices, but it's different. It's different. The prices are different even within the same cloud operator. So we wanted to have opportunity to make some informed decisions about if we want to focus more on if it's worth paying for a small difference in latency in ping. So that the other thing was that we wanted to be able to assign some weights to the decisions. If latency is more important or price is more important, that would be to be decided by the session assigner. And also the problem was availability, because if you want to have 1 or 2 or 10 virtual machines, usually it's not a problem. But if you want to have 500 of them, because we are expecting a huge peak in traffic, it might not be that easy. So if some cloud operators would have some problems with providing those virtual machines, we could ask some another cloud operator for that capacity. Also, there are some regions that are not that easy to put our servers in. Sometimes it's even not possible to connect using the to spawn new servers using the standard clouds, typical operators. So for that regions we would have just another session assigner and work with that region separately. Okay, but yeah, that sounds interesting that we have that opportunity, but it's not all that fun that it's to run multi-cloud. First of all, we have to pay for. Usually, you have to pay for the traffic that's going outside our main the home network, let's say. So if we have our services within the infrastructure of one operator, traffic. Outgoing traffic to our, for instance, game servers. If we have a lot of traffic going to the game servers from our backend services, it could be expensive. The second thing is the security problems, because we would have to expose more endpoints to other cloud infrastructures. So if we have everything in a single cloud, it's easy, because the internal traffic is internal traffic. It's not going outside. It's not that easy to be sniffed and so on. So if we want to use multiple clouds, we have to make sure that traffic between is safe and all the network is secured. The other problem is that if you use multiple clouds, it might be a little bit overly complicated when it comes to some little quirks that every cloud operator has. Like, for instance, every cloud operator provides some kind of hosted Kubernetes clusters, but there are tiny differences that might be very tricky to track and to see why something is working in one cloud and is not in the second. So that might be a little bit complicated, and like Tyson Singer from Spotify said, it's they decided that there is this simplicity in having a single cloud. It was much easier for them to focus on a single cloud, and yeah, it might become overly complicated if we use many of them. So we decided to test how it goes with the multiple operators, and we deployed the session assigner agents to each of the cloud operators. So we had duplicated infrastructure, like triplicated, and we used the same generic Kubernetes clusters. We had the same assigner agent within the infrastructure of all of them. The session assigner had the addresses of hardcode. Just for our test purposes, we had hard-coded the addresses of the agent, and after deciding which cloud to use, the session assigner just asked for providing the game server, returned the address, and that was it. So it appeared like much easier than we expected, because we are expecting a lot of issues with the connections, but we just deployed them into different clouds, and it just worked. But as I said a moment ago, each cloud operator has some special offers for game dev. they have their own services for that. And they usually expose some APIs for deploying new instances, for assigning them, and so on and so on. So we've created a dedicated assigner agents for each of them. And yeah, so the microservice infrastructure was allowed us to create some very small replaceable components that that were working hand in hand with the services the cloud the vendor operators provided. So, for instance, we created the assigner agent for the Fleet IQ of Amazon, and also for PlayFab in Azure. So we were able to use all these special pricing, special assigning, special cheaper instances for our game servers within the same architecture. We had we just kept the same contract, the same API for all the session assigner agents, and we had no problems with that. But like I said, the bare metal is much cheaper than the cloud, and we chose we made a decision to test one more thing. As usually the multiplayer games have some baseline traffic that's more or less doesn't fall down below some kind of traffic. We even when you take into account some daytime, nighttime rhythm, we have players all over the world. So the day is moving, and there's some baseline traffic that we can host using dedicated bare metal servers, and everything above that we can offload to the cloud to make sure that every player will have some capacity to have the game server hosted, and for the baseline traffic we'll use the bare metal servers that are just cheaper. So we created another session assigner agent. This session assigner agent just kept the addresses of all the bare metal servers, and if that of course that assigner agent had priority over any other. So when capacity on that servers was used, we just started using other session assigner agents in the cloud, and we are able also we could just mix and match. We could use generic approach in Kubernetes in the cloud, or use some vendor-specific offers. Okay, so few takeaways from what we've learned. First of all, the cloud can take a lot of burden from you. You don't have to have a lot of people for just the bare metal maintenance, because it can become a heavy burden if you have to take care of just failing hard drives, some fans being clogged by dust and things like that. You have to keep all the network operating center for 24/7 just to make sure that everything is working fine, or pay someone to do that. With cloud, you just have to make sure that your infrastructure is deployed properly. It's not that easy, of course, but it's also up to you if you want to go to the lowest level of the cloud, meaning infrastructure as a service. You can pay someone to host your applications with the other service tiers. Sometimes the single cloud operator is not enough. When you have some very specific use cases. If you want to host your games in some regions that are not being hosted in standard, that are not being served by standard cloud operators, it's helpful to use multiple operators. But on the other hand, it has issues on its own. So it really can become complicated. From our experience, it's much easier if you use generic services, meaning if you have experience with Kubernetes, you can just go with it because all the operators provide some kind of hosted Kubernetes clusters, and it makes transitioning between clouds much easier. Make sure to check for hidden costs because the prices, let's say prices for the cloud services are quite obscure. It's so obscure that people are creating some user-maintained calculators to check how much you'll actually pay, because there are some things that you might not take into account. Like first of all, you have to pay for the virtual machines, for the internal traffic, external traffic, incoming, outgoing traffic, the connections, meaning that besides the bytes that you're going to transfer, you have to pay for each request. So it might be people had many issues that they got the bill that they weren't able to pay. So make sure that you'll know everything. And if it's possible, avoid increased complexity because maintaining that might be difficult for smaller teams. Thank you very much for listening to my presentation. I hope that you learned from our experience. We had a lot of fun playing with the different kinds of architectures, with developing the small moving components and moving them between clouds. So that process was very satisfying. If you're interested in that topic, like I said, tomorrow I have a second session dedicated strictly to the services offered directly by the vendors. So that might give you some insight about what can you use in the cloud if you don't want to keep the infrastructure by yourself, even the cloud infrastructure. Of course, we are hiring like everyone. So if you are interested in developing the online services for us, just let us know. We have the booth just downstairs. Thank you very much.
Thank you, Leszek. And if you have any questions, this is a great time. So please just stand up and come here on the stage. There's a microphone, and feel free to ask anything.
And if not now, I am just around here. Just go ahead. But afterwards, I am just around. So go ahead.
Hi, I'm Pavel from FryandJelly. So yeah, we're developing a single-player game right now with FryandJelly, but we're also going to make a mage dueling game, which we really need to scale up majorly. And my previous job as a CTO, I also did some stuff that you guys are doing here. And actually, as you were talking, I had questions that you kept answering. Like I was going to ask, why not a hybrid approach? And you just went there, so you took away my questions. But I do still have a question, which is like, obviously there's some heterogeneity there because you have bare metal and the different vendors and all that stuff. So could you maybe say something more if you ran into what were like the most serious problems to maintain the homogeneity that you needed to keep everything working together and orchestrating everything well enough?
Yeah, like I said, we really like Kubernetes. So even for the bare metal, we've deployed Kubernetes clusters on our bare metal.
Right.
So we had exactly the same containers deployed on our bare metal in the cloud, in the cloud-hosted Kubernetes clusters, and also we used Docker containers for there's Azure PlayFab that's also allowing to use exactly the same Docker containers to be run. So So that made everything really easy to scale out, because we use that approach for instance when we are preparing for bigger releases of Gwent. So we had our game servers prepared to be scaled out in the cloud. So it's we didn't have to provide to build anything to make any changes to the game server themselves.
Okay, and if I maybe so bold with just one other question, did that solve the cost effectiveness issue for you guys also, or did you have to like also use those user maintained things, or did you develop something extra to keep everything in check in terms of costs?
Actually, we've decided we had the bare metal servers previously. They were up and running, and we've decided that above some level, like not above the lowest level, but we've decided, okay, at some point this is the point when we will start to scale out in the cloud. So we had. We were able to, we created in our administration panel for our game servers, we created option just to scale out, and after that we started using the servers in the cloud, and they were auto scaling just after the capacity was reached, and that was it. So we had almost
no surprises.
No surprises.
Okay, thank you.
Sure.
Hi Leszek, thanks for a great presentation. So at the beginning you mentioned that you tried 3 different vendors, basically cloud providers. So I'm interested if you could just quickly compare them together in terms of like money-wise, resiliency-wise, what was kind of like the nice things about them, and which one, if you could just like pick one, with which one would you go?
That's a very difficult topic because we didn't do that kind of comparison. Like at some point we were of course making the calculations what is the cheapest solution, but we've decided that it's not the biggest topic, that because the difference wasn't that big. We actually, I know it's difficult to believe, but we had no issues with stability. We had, of course, there were problems like I said with the noisy neighbors and so on, but I couldn't recommend just one, because I do not think that one of them is much better than the others with regards to the generic services. Because we've used the Kubernetes services, the hosted Kubernetes, which means that there are they have almost the same names, like EKS, AKS, GKS, and we use all of them, and we had no problems with that. But if we got to the comparison of the game dev dedicated services, those are completely different breeds of animals. Like they have different levels of services, different offers, and I would hardly say it depends. So yeah, it's everything depends on what you expect. Right now, I would have to cover most of my tomorrow presentation about what they offer, but it really boils down to what you need and what you want to get from the cloud. So I invite you to my tomorrow talk.
I'll be there.
Sure, and I hope tomorrow at that talk tomorrow I'll be able to solve all your questions.
Okay, thanks. I actually have another question. So at the beginning of the presentation, you mentioned there is also function as a service. Mm-hmm. And have you tried and have you maybe thought about including that into your workload? Like there was that session assigner. Mm-hmm. It looked like a nice candidate for a serverless.
Yes, we were discussing if that's for us, but we had no experience with with working totally serverless, because we had experience with Kubernetes, with bare metal, with virtual machines, and also the problem was that the function as a service usually is using languages that we also had no capacity. So it's mainly Python, sometimes JavaScript, sometimes something else, but we had no capacity of developing that. We had ready to work code in Java, in Golang. We had some legacy in PHP, but it was nothing that was actually possible for us to use on the spot. So we were looking at that. Also, there is the project from Amazon. It's called GameSparks, which is function as a service, but it works in a software as a service manner. Like you choose, okay, I want to have achievements, and it's being deployed as ready to go function as a service. So if someone wants to work that way, it's still in beta, and there are not too many services covered by GameSparks. But it's if you don't want to support that code on your own, it's possible to go that way.
Okay, thanks.
Sure. Okay, thank you very much. One more? Someone more? Yeah, go ahead.
Hello.
Hey.
I have a quick question about what's the overview of this approach, like handling different vendors and bare metal on top of it, versus the goal you wanted to achieve, like lower latency for the players. How does it go, or like relate, and was it worth the effort?
For us, as we already had the bare metal, it was easier for us just to support that than to sell all the just go out of the bare metal approach.
Okay.
And also we use that in Gwent, where the latency is totally not important, because it's a card game. Latency is not that important, but we had to take that into account for our future games. So right now we have bare metal, and we have some offloading into the cloud for Gwent, but for the future it would be most likely different clouds without bare metal.
Okay, cool, thank you.
Sure. Okay, I will wait. Okay, I think we're good, and like I said, I'm just hanging around, so if you have any questions, just go ahead.